Are we waiting for somebody or should we begin?
Just 1 minute. Let Ramana Murthy sir join.
All right. Good afternoon.
Hello, ma'am. Good afternoon.
Good afternoon.
Thank you for joining us, ma'am.
My pleasure.
Ayush, I've shared Ramana Murthy sir's number. After sending it to him, you coordinate his joining.
Yes, sir.
Nishta will start.
All right. So, good afternoon, everyone. It's with great pleasure and immense pride that I welcome you all to the webinar that we are hosting today on the occasion of World Oceans Day 2024. This event is being hosted by Maritime Research Center in collaboration with Needs Money Technologies and Indo-Swiss Center of Excellence. Today, we come together as MRC interns, MRC fellows, MRC internal team members, and distinguished guests and invitees to celebrate and reflect on the vital importance of oceans. World Oceans Day is a global reminder of oceans' crucial role in sustaining life on Earth. Covering over 75% of the planet, our oceans are the lifeblood to the ecosystem, the regulators of our climate, and the source of sustenance and livelihood for billions of people. This year's theme, which was set by United Nations, Awaken New Depth, highlights the urgent need for collective action to protect and restore the health of our ocean. At the Maritime Research Center, we are committed to advancing our understanding of marine ecosystem through cutting-edge research, innovative technologies, and collaborative initiatives. Our dedicated team of researchers, fellows, interns, and partners work tirelessly to develop solutions that address the complex issues facing our oceans today. Today's webinar brings together a diverse group of experts, advocates, enthusiasts who share a common passion of ocean conservation. Throughout the day, you will hear from our internal team members, our summer interns for 2024 batch, who will shed light on the latest research findings, conservation strategies, and policy development. We will also engage in thought-provoking discussions on how we can collectively contribute to the well-being of our oceans. To our MRC interns and fellows, you represent the next generation of ocean stewards. Your dedication and enthusiasm are vital for the continued success in our mission. As we embark on this journey together today, let us remember that the health of our ocean are intrinsically linked to the health of our planet. And thank you all for joining us on this significant day today. Let us be inspired, informed, and most importantly, united in our effort to protect and preserve the oceans. Welcome to the World Oceans Day webinar 2024. Starting with today's World Oceans Day webinar, I would like to call upon Dr. Commander Arnav Das, who is the founder and director of the Maritime Research Center and Needs Money Technologies, to share his welcome remark with all of us and guide us for today's presentations. Welcome.
Thank you, Nishta. Happy World Ocean Day, firstly. And we are extremely honored to have a very special guest, Dr. Satish Shenoy sir, who's also the chairman of our Research Advisory Board. And Radhika ma'am is also part of our Research Advisory Board. Dr. Shabana Barua is also here. She's from the strategic background and she joins us from ICWA. We have tried to see that we get different dimensions. And Dr. Ramana Murthy sir, Director, National Center for Coastal Research, is going to be joining us very soon. He's got a little problem in logging in, but I think that will get sorted out sooner. We were also expecting Purvaja ma'am from, she is the Director of National Center for Sustainable Ocean Coastal Management, but unfortunately she is unwell, so she is not able to join. The World Ocean Day celebration at MRC is typically to showcase the work that we are doing. And normally this is the time when we have our young interns also who join. And we've been doing this for a few years now. And they present the work, and it also we take this as an opportunity to showcase the diverse kind of work that we do. Just to give you a sense, I just want to quickly share my screen, and I'll just take very little time. Just to remind you of the UDA framework, and you can see the different cubes that are represented in this. And we try to see that our young interns populate the smaller cubes that you see. So diverse projects, diverse multidisciplinary ideas are kind of attempted here, and each of the project takes a little while to mature. So our way of working is very, very simple and straightforward. As soon as the intern joins, we give him options of what kind of projects they could do. Uh, we are very happy to say that we get very good students. I mean, the interns, they come from very good institutes. This year, IIT Bombay, Kharagpur, Delhi, and Chennai, we got over 500 applications, and it takes a lot of effort from my team to kind of select, because we don't want to take too many people, so because we want to give very personalized attention. So we cut it down to much smaller number, so that we can have a one-to-one interaction, and it's a very intense. So some of the interns actually find it hard to continue because it's a very intense. I mean, my entire team is involved, and we have a very good set of team which looks at all these aspects. So what you can see is that all these projects, first and foremost, after the intern has finalized the title of the project that they want to work on, they embark on a literature survey, which culminates into a research note. So the research note basically gives a few of the research directions based on the literature survey that they do. We have probably almost 200 research notes already in our knowledge center. And now we have also started another section which is called the innovation notes. So if it is a very intense technology or technology development kind of a project, then they also go into an innovation note, which basically specifically talks about certain I mean, we could also call it a startup idea. So it has been, the innovation note has been designed in that manner. So after the first research note is completed, the intern is then asked to finalize a flow chart, which basically defines the scope of work, having done the literature survey, and also what kind of resources the intern would require to complete the project. And then they also write a small 1,500-word article, which we call it the UDA Digest issue brief, which basically announces what this project is and what the project aims to achieve. And that is published in our UDA Digest platform, which I think now has more than 120 articles of different types. You'll be given more inputs on that. And then they move on. Once the project is very clearly defined, the scope is defined, then they move on to either a second research note. If it's a policy kind of a work, then it goes into another research note. But if it is a technology work, then it goes into a innovation note. And then at the end, they would submit a short report, which kind of summarizes what they have done and how what have they achieved. So this is a broad journey of an internship, and once they complete the internship, some of them also continue with us as a research fellow. So we are happy to, you'll be meeting a couple of our research fellows also, who, I mean, we have some of them who have been with us for more than 2 years now. And so they look at something more serious, and they take it forward from that perspective. And now they are also guiding the next lot of interns. I mean, the research fellows who have spent enough time and they have a lot of experience. Apart from me, Sridhar, Catherine, they also mentor some of the interns, because it becomes more specific to their domain. You will get a sense of all this that I'm trying to tell you. So now the digital transformation has become a very, very important issue. So I want to just draw your attention to marine special planning. Shenoy sir and Ramana Murthy sir will definitely relate to this, that this is now becoming a very, very important aspect. So we look at marine special planning in a very, very different manner. We are focusing on the modeling and simulation approach, because conventionally the Western approach is data collection and very intense sensor deployment, which is, I feel, very, very cost intensive and also hardware intensive, which is sometimes I would say it is not viable. So what we propose is a modeling and simulation based approach, followed by a detailed field experimental validation. So this is one example of that, where we have used AIS data to make this map, and it also captures the local tropical conditions. So, I mean, I just want to draw your attention how this is done. So the AIS data gives the complete shipping data, and then the vessel machinery details is taken from another database. These are all available databases, that are online databases that are available, and they are real-time available. On the other side, you see real-time data available from the Itopo database, and these are captured, and the channel model is for the tropical waters is computed, and these both are combined to get what you see here. So, and then you can we validate this at certain location. So something like an Indian EZ, which is almost 3.7 million square kilometers, can easily be mapped onto by using this kind of a method, and this will be extremely cost effective and efficient. So that's the approach we follow, and that is what you'll see different dimensions of MSP as we move forward. So I think I'll stop here, not take too much time, and I'll hand over back to Nishtha.
Thank you, sir. Thanks a lot for apprising us of all the details that you just talked about. Moving ahead, I would like to welcome Dr. Satish Shenoy, sir, who is the member of MRC's Research and Advisory Board. A little bit introduction about Dr. Satish Shenoy. He's currently serving as the director of the Indian National Center for Ocean Information Services, INFOIS. In recognition to his outstanding research contribution in the field of ocean sciences and technology, the Ministry of Earth Sciences honored Dr. Satish Shenoy with the National Award in the field of ocean science and technology for the year 2018. So thank you very much for joining us, Dr. Satish Shenoy. We would like to welcome you.
Thank you very much, and a very good afternoon to all the participants of this celebration of World Ocean Day, and wish you all a happy World Ocean Day. At the outset, let me thank MRC, specifically Director Commodore Dr. Arnab Das, as well as other colleagues of his. Mrs. Catherine is always on touch with me for such functions, and provides all the information. So thank you very much for inviting me to join this celebration. Just a small correction. I am former director of INQUIS. Currently, I am working as chair professor of Ministry of Earth Sciences. It's a post-retirement. Just to made it known to all the participants. When we talk about the World Ocean Day, which was formally announced by the UN General Council in 2008, because oceans are getting more and more prominence because of the evolving world order, because in several aspects, and as we know that the same oceans are coming under threat now. Of course, the oceans are strategically important for various reasons, for trade, commerce, etc., and for the security and peacekeeping in the world itself. but the threat on the ocean has increased more from global warming and climate change now, and also because all the pollutants are finally ending up in the oceans. So it is a bounden duty of all of us to look for a clean ocean free of plastic pollution, because plastic is the major pollutant which has been observed in the oceans till now. Of course, other chemicals are also pollute, and most of them remain as a local pollutant rather than worldwide pollutant. But plastic is no longer like that, because first of all, the plastic cannot degrade, and it never dies even in our four generations lifetime. It stays there, so it goes anywhere. It goes from India to US or Japan or somewhere that far, as well as it goes down to 5,000 or 10,000 meters below the water column and pollutes the entire water column. So I think we have to keep our work as well as our efforts to achieve a clean ocean free of plastic pollution, and healthy and resilient ocean where marine ecosystems are understood, protected, restored, and managed. Similarly, a productive ocean supporting sustainable food supply, because we all know that the oceans provide the uh, major chunk of food what we consume, especially the protein in the form of marine fisheries and other mollusks and other forms. So we have to the ocean should be productive, but at the same time it should be sustainable, so that we will not deplete the food what we are getting from the ocean. And we should be putting our efforts to predict the ocean, where we understand the ocean and we are able to predict the ocean. Actually, that is one of the major job which Inquis is doing. Inquis provides these day-to-day predictions of ocean state, comprising of what would be the waves, wave height, wave direction, wave periods, as well as ocean currents, ocean temperature, salinity, like that, several parameters. So we should be able to predict that ocean, so that we can conduct several planned activities, as well as we can have safe navigation and safe fishing. And those predictions are right now used by from fishermen to oil and natural gas companies, and they get the benefit of knowing the state of ocean in advance and planning their activities. Also, we want a safe ocean where the life in the ocean is safe, and the livelihood of the people who are depending on the ocean are protected, and they are not getting affected by the depletion of the life in the ocean. Or because as we know that in India itself we are about 40,000 40 lakhs, not 40,000, 40 lakh people who belong to the fishing community. Their entire life is depending on the fisheries in this country. So their livelihood should be protected. So to protect that, we should have abundant fish, and not depleting from the fisheries point of view. So we should have a safe ocean. And at the same time, those who live on the coast, we know that they are facing several hazards, like the storm surges. That is the most common hazard which people, the coastal population is facing. And once in a while, but it is more lethal, the tsunamis. Inquis provides predictions on storm surges. It tells the coastal districts where the storm surge is going to get affected, and what would be the effect, like how much it will inundate that land, and how far inside it will inundate, so that the disaster management agencies can take the necessary steps, as well as the tsunami early warnings are provided by inquiries, so that our coastal communities, not only the fishermen who are living on the coastal areas, there are other infrastructure, other several valuable infrastructure like power plants and ports and harbors, also, as well as other commercial activities and townships. For example, uh, for three of our metropolitan cities, Calcutta, Chennai, and Mumbai, these three largest cities of India are located right on the coast, and they're not very much higher level than the sea level. So, if any of these hazards occur in those areas, the not only the human life and human loss, the economic losses are also going to be too high. So we should be prepared for that prediction and how to deal with such situations. So we should have a safety net for to cover all that, and our ocean should be accessible and equitable access to data, so that if the data is free and accessible to all researchers, for example, the centers like MRC, you can also do research. If data is not shared by other institutions or others, so we have to advocate for and free flow of data, so that the knowledge can be derived from because data is only data alone, or it's just a information, but the knowledge has to be derived from that through the research by various researchers, so that the centers like MRC or any other center also can get benefited. So these are some of the issues which I think we had to keep in mind and take it forward. And we had to reiterate that we will work for these issues on this day of World Ocean Day. And before I conclude, let me also mention about the diversified work which the MRC is engaged in. I see MRC's work in three categories actually, because of my association with MRC for the past few years, and also getting the first-hand information on attending such review meetings. One is the science. There are projects which are working purely from the point of view of science, and second category are the technology-driven projects, or they are trying to develop some or other technologies. And third is more on the policy research, especially the strategic importance. I think this is a good combination, and I haven't seen any other institution in India getting engaged in all these three diversified kind of topics, and working from the same under the same roof to achieve all these three diversified goals. One is policy research, as well as technology and science research. And I wish all the best for MRC on this occasion, and look forward to listening to some of the um, uh, talks by the youngsters who has already carried out. Of course, I have heard about most of the youngsters earlier as well, but I am sure there are new students also in this group for today's presentation. So I will let me see how much I can prolong, because I have another meeting also to attend. So I will stay on for as much I could. Otherwise, please excuse me if I log out in between, because I had to join another meeting little later. So with these words, let me once again congratulate MRC and its staff, as well as director, staff, and the students and interns who are working at MRC. And I must also congratulate or appreciate director as well as the planners of this function, that instead of keeping just one or two lectures, they have asked they are going to have a sort of a review. Actually, on the celebrations day, that is what we are supposed to do. It is not that just a celebration. We have to look back and review what we have done and what we can do and what we could have done. So I think this planning is very good. I appreciate that. So with these words, let me conclude and thank you. Namaskar, Jai Hind.
Thank you so much, sir. Really appreciate your comments, and as you guided us, sir, we are also, I mean, we have divided our team into three broad categories. As you said, policy is definitely important, but backed by technology. So we have a technology team also, and these are one of the best people working in technology areas. And the third aspect is we also have, we call them MRC engineers, because there's a lot of infrastructure required to carry on research. So now we have, in the last 1 year or maybe 1.5 years, we have started focusing on the backend infrastructure which will support the research. Although we are a very small organization, but my team led by Sridhar Prabhuraman, he's unfortunately not well today, so he's not here. But he has been focusing on the infrastructure as well. So you'll get a flavor of the presentation has been planned in that manner that you'll get a flavor of all the different types of work that we are doing. Uh, uh, Before I hand it over back to Nishtha, I would also like to warmly welcome Ramanamurthy sir. He could not join initially because of some technical issues, but thank you very much, sir, for joining us. And we take this opportunity to showcase our work to you. And so I'll hand over to Nishtha to take it forward.
Thank you so much, sir. With this, we move on to the next segment, and we'll have three presentations in the next segment, wherein the research engineers from the Maritime Research Center will talk about their work and what they do in the backend work and the data analysis and other things that they do. So firstly, I'd like to call upon Ayush Sagar, who is a research engineer at the Maritime Research Center. Ayush is going to be taking us through the program of the internship that happens at MRC, and also he'll talk briefly about the UDL platforms that we've built over the years. Ayush, you may take over.
Yes. Good afternoon, everyone. I am Ayush Sawat, a research engineer at MRC. In my role, I focus on coordinating internships, managing our website, and organizing events. Today, I am excited to present an overview of our prestigious internship program at the Maritime Research Center, and I will also give an overview on these 4 UDA platforms that we run. So, the Maritime Research Center has its multiple internship programs throughout the year. The internship could be for 8 weeks, 6 months, and up to 1 year for multidisciplinary students, and also for professionals and faculties who would like to upgrade their career opportunities. So it will be a project-based program, so to expose the participants to multiple issues and aspects based on real-world problem solving. And now we have also came up with this structure that if a student or any professional is interested in doing internship, first they have to go through the e-learning modules, which is mandatory for internship. Then I am thrilled to announce that we have also received 500 plus application from different IITs across various domains for our research internships, which span a duration of 2 months. Then our backend team shortlists this application, followed by 2 rounds of interview. The first interview is a communication round where we assess the students' interest and basic communication skills. Then second is a technical round where we evaluate their technical expertise in their field of study and their knowledge of underwater basics. So once they are selected, interns undergo a comprehensive onboarding process. This includes orientation session led by our experienced team, and all the information and resources are provided to help interns get started. So each intern is then assigned a specific real world research topic to work on for the duration of the internship. Over these 2 months of internship, they have to submit their deliverables like mind map submission, 3 UDA digest issue briefs, innovation notes, research paper, and the final project presentation. After successfully completion of this internship, certificate and letter of appreciation have also been awarded to the students. And interns, those who showcase outstanding performance, are also offered research fellowships. Then coming towards the four UDA platforms that we run, we have UDA Digest, Learning Center, UDA Dialogue, and Knowledge Center. So going to each platform. So this is the UDA Digest. It is a basically e-magazine which was established in the year 2021. And by the time 2022, we started receiving articles from the experts of the domain. And it has four formats. If you see, issue briefs, commentaries, expert articles, and short reports. So only the fact that these differ from each other are the word limits. Then around 100 plus articles have been populated over here in a different categories: maritime security, blue economy, skilling India, and this. And moving towards the next platform, we have this learning center. So we have created a series of e-learning modules, which has also been populated on the government website. I got Karmayogi, the government website, and it has been uploaded to sensitize the diplomats and bureaucrats. Then we have this four upcoming modules also that we will be populating soon. Then moving towards the next platform, that is UDA Dialogue. So we have conducted many events, workshops, seminars. So all the video audio part has been uploaded over here. So video has been divided in these 6 categories, which has events, workshops, research, entity, product, expert talks, and upcoming events. So if you click on any of the category, you will see all the information about the events that we have conducted. Then if clicking on each event, then you will see a small information and an attached video with it. So moving towards the next platform, we have Knowledge Center. So over 150 plus articles have been, research notes have been uploaded, which has been done by interns and fellows, along with the innovation notes. So case studies we will be populating soon, and it is under Harvard University model, where real world problem solving is given in a proper way. So with that, thank you for your kind attention.
Thank you, Ayush. Next, I would like to call on Shreya Wagmare, who's again a research engineer at the Maritime Research Center, and Shreya is going to be explaining about MRC's digital infrastructure.
Thank you, Nishtha. Yeah. Good afternoon, everyone. I'm Shreya Wagmare, and I'm mid-level engineer at Maritime Research Center, and I manage the digital infrastructure at MRC. So today I would like to talk about how the digital infrastructure powers MRC's operations, which makes us to function efficiently and effectively. And I'll give you a small tour of what digital infrastructure is and how it's a part of UDA and its digital transformation. Also, I will talk about the capacity and capability based on the digital systems. About the UDA and digital transformation, my approach to this session will be solely based on the digital infrastructure point of view. Yeah. So moving ahead, first I'll give you an idea about what digital infrastructure is and how it makes the difference. So digital infrastructure is like a foundation of services or tools which supports the use of each and every digital technology that we use daily. So like it includes everything, like it is cloud computing, whether storage, whether it is servers. So at MRC, digital infrastructure plays a very important role as it reduces the offline management of all these hardware systems. And as you can see, all these due to digital-based cloud-based infrastructure, we we can see the huge percentage difference uh, between what to do and I mean, how much capacity of research and development can be increased through the online digital infrastructure, and it reduces the management part of this hardware structure by a remarkable percentage also, and that actually makes a significant difference in how MRC works. So to give you an idea, so this the UDA framework, this figure, it provides a clear path for stakeholders like strategic security, digital transformation. So all of them to engage effectively and collaboratively. So in which digital transformation plays a very important role in acoustic capacity and capability building. So the way Cube refers to the sensing and analysis regulation. So it is all backed up by the support of safe and secure digital infrastructure. So now let's see what are the components of infrastructure that enhances this capacity and capability building. So as I mentioned, implementation of UDA framework, it is backed by a huge research team and innovation team, which includes various research projects. So they mostly work on the real-time data processing, analysis, modeling and simulation, and that requires a higher computing power as well as storage capacity also. And that is actually available at a single click of a button. And this is possible due to the integration of and use of this digital infrastructure. And to mention just few of them, so one of the services that we use for expanding the capacity of computing as well as storage. So AWS is one of the services that are integrated into our projects. Also for data security and management, so it is very important for each project, and that is actually backed by the services like Bitbucket and GitHub, which also allows us to use data repository and control the versions of it, whether we have to use the current version or the older version of it. So also to sum it up, these services are actually bound up by every member at MRC, whether it is engineers or interns or research fellows. So they are actually collaboratively working on a platform like Microsoft Teams and their services. So MRC's vision let all of us to continue to embrace and utilize our digital infrastructure to the fullest potential that it can give to us. And I would like to I would like to end up on a note that digital infrastructure is not just about the technology, it is about rethinking your entire business model. And thank you, everyone. And I wish a very happy World Oceans Day. Thank you.
Thank you, Shreya. Next, we move on to Jay. Jay Pinjarkar is also MRC research engineer, and Jay is going to be speaking about the UDA database management.
Yes. So my name is Jay Bhanudas Pinsaka. I'm working as a research engineer at MRC. So in MRC, I mostly handled the technical part related to the MSP and along with the research work in it. Alright. So going about the UDA data management. So our vision at MRC is very simple and clear to keep the data in accurate, consistent, and accessible along all the organization. By considering the compliance with the digital data security, also by understanding its scalability. So by considering the major aspect of marine spatial planning, the data is a major thing that need to be managed in a very accurate way. So we have the infrastructure, cloud-based infrastructure, which was very secured, and the MSP that MRC proposed is completely based on the modeling and simulation. So we structured our data by considering the modeling and simulation part. So we divided the data in two major parts, that is open source data, and another one is a field data. So in the in open source data, we have performed the modeling and simulation parts. So likewise, the upcoming interns are also going to talk about the advanced collision avoidance systems by using the AIS data and SAR data. Mm. And one more project is there from using the SAR data, the detection of the aquaculture ponds. So that's how we build the model using this data. Apart from the only the open source data, we have the MOs with the different organization. So that can be also used to build our models. Going to the field data, so according to whatever the project need to validate the model that will build. So to validate the models, we itself perform some validation data field on-field validations also. So likewise, we did in the Kharar Swasla Dam. We also have the Goa datasets and Ganga datasets also. Along with that, whatever the research has already happened, So whatever the data source or data sets are on field are available on the trusted for platform. So we also refer them. Likewise, the AI data sets are also available. So this data is organized in such a way that it is accessible to all the entrants, the researchers in a very useful manner, because lots of rework is reduced by organizing this data. And we ensure that at MRC the data will be very stored in a very secured way. Yes, that's all from me. Thank you.
Thank you, Jay. Thanks to all who presented in this segment. We'll move on to the next segment now. We have the MRC project presentations, and all of the four, like there are sets of presentations that we have. The topic number 1 for today is sediment management, and this topic is going to be led by the MRC fellow Romit Kavre. So now I'd like to call upon Romit Kavre, who is an MRC fellow, and he's done his studies from IIT Delhi. Romit is going to be making a presentation on a topic which is going to be inclined towards sediment management in tropical waters of the Indian Ocean.
Hello everyone. I am Romit Rajendra Kavre. So I'm working as a research fellow at MRC. I graduated from IIT Delhi with a BTech in civil engineering, and now since the past 2 years have been working on the sediment management in the tropical waters of the Indian Ocean. So that's what I'll discuss today. So the thing is, we talk about sediments. Sediments are very crucial when we talk about the freshwater systems or the coastal dynamics as well. But how their dynamics work, it's not clearly understood. In fact, the efficient management of these sediment holds economic, social, as well as environmental consideration. Now, when we talk about the sediment management, we are mostly focused on the two aspects, which is the sediment classification, which I will talk about later, and the sediment transport studies. Now, this sediment transport study is very much crucial in the global geochemical cycles. So, when we talk about the land use, the sediment erosion rates, human interventions, all of these emerge as a primary factor which influence the sediment influx into the various coastal or the freshwater systems that are there. So when we talk about the sediment management, we are mostly focused on the freshwater system and the coastal regions. So in the freshwater systems, we have the major river basins that are there. We know the Ganga and the Brahmaputra rivers. Now these carry excessive sediments when we talk about the monsoon season is there, which leads to a lot of sedimentation, especially in the Sundarban Delta region or in the Bay of Bengal region. Then there are the various reservoirs that are there. Due to the excess sedimentation, the Central Water Commission says that there is an annual reduction of 1.5% storage due to this sedimentation. This also has implications for water quality when we talk about the inland water transport and all. Apart from that, when we talk about the coastal regions, so there are various ports, inland water transport is also there, and the sediment management basically controls the operations of these crucial regions. It influences the navigation of efficient operations of the of shipping, navigation, and all. Apart from that, they also house various estuaries, coral reefs, mangroves, and other marine ecosystem hotspots are there. And with the advanced with the high human activities that are there in the exclusive economic zone, all of this pose a major challenge, including pollution, overfishing, then there is the underwater radiated noise. All of this affect the coastal regions. That way these two freshwater system and coastal regions needs to be separately understood. And now when we talk about the other aspect, that is the sediment classification. So it basically means we are trying to understand what is the seabed composed of, what are the various sediment types, what are the various layers under the water of sediment. Now this plays a crucial role uh, when we talk about the various biotic and the abiotic aspects of the marine ecosystem. We are mostly working on the three broad applications. The first one is the sediment bearing pressure, which is required for the foundation foundation design of the offshore infrastructure, like there may be various oil rigs and all, or offshore bridges and all. Then there is the benthic ecosystem assessment, which is basically understanding or basically monitoring the well-being or the quality of the life at the bottommost or near the seabed or the riverbed that is there. And then is the abiotic element detection, where we talk about the marine litter that is suspended in the sediments, or about the polymetallic nodules are there, or offshore oil and gas exploration. So all of these applications come under the sediment classification, and uh, all of the monitoring and all is greatly affected by the texture of the sediments, how is the distribution, basically the topography of the various sediments that are there. Another major task is understanding how the sediment plays a crucial role in the dredging operations. So when we talk about the port systems or the inland waterways, dredging is constantly taken up. But what we fail to understand is how does this sediment dynamics affect the constant dredging. There, due to the various coastal dynamics, water dynamics, or other human interventions, there might be a redistribution of the sediments, which would require dredging again and again. So annual dredging might be required. Now this is time consuming, this is expensive as well, and it affects the marine ecosystem and other channel characteristics as well. We have not been able to clearly understand how the sediment dynamics plays a crucial role in these the dredging operations. Uh, so what is happening now with the advent of the Internet of Things, the 5G technologies there, or artificial intelligence, we can have this real-time data feed can be done. So say we are having dredging operations, we can directly have a real-time feed of understanding how it is affecting the seabed, or the understand how the marine ecosystem is getting affected. Similarly, with this 5G technology, we can have real-time data sharing, so we can identify what are the various stakeholders that are there. There might be operators, then policymakers or the decision makers that are there. We might be able to share data, and with the rise of cloud computing, we can cloud computing, various data storages are there. We can have real-time data analysis skills as well, in order to have proper monitoring or proper interpretations of the data that are being collected to make informed decisions. When we talk about data, we all know that without data, we can't properly understand what is the current local situation and formulate holistic plans. So collection of data can happen through various optical sensors are there. We have acoustic sensors that are there that can be on board the remotely operated vehicles, or the AUVs are there. Large scale modeling and simulation tools have also been developed for a large scale understanding uh, of our vast oceans. But all of this require a significant amount of data, and as we know that the Indian Ocean lacks significant amount of data. Whenever if I talk about even bathymetry as well, the MH370 case shows that a mere 2 to 3% of the seabed is being studied for bathymetry. So Indian Ocean lacks the most basic data as well. But when we talk about data collection and all, we fail to understand what are the crucial tropical conditions. Now the Indian Ocean is more is warmest amongst the Pacific Ocean or the other major oceans or water bodies. It contains rich biodiversity. It has mangroves, various coral reefs are there, which again needs to be properly assessed. And then the rise in human activities, it's a hub for global shipping, oil and gas, and there are various economic activities that are going on. How they affect the working of the various sensors. We have the ambient noise that is being generated, how this affect the acoustic systems. Apart from that, when we talk about acoustics, the tropical waters, the SOFA depth, which is very much crucial for the efficient underwater communication of the acoustic systems, it lies at the greater depth in the tropical waters, which leads to inefficient operations of the acoustic systems that are there. Thus, whenever the systems are being developed, we have challenges of background noise, which comes from the various biodiversity or from various economic activities that are there. Now, this leads to the problems in deployment, calibration, and maintenance. There are various constraints for the equipment and the operational cost of these acoustic sensors. And thus, whatever systems that have been mostly imported from other part of the globe, the efficiency reduces to around 60 to 70%. Now, what does it do? It makes India reliant on the Western technology rather than developing our own systems. Thus, what we are trying to understand is, for each of the applications of sediment management, we can have this 2C, to understand to share model for the data collection. So in 2C, we can understand what are the various hardware requirements, various sensors that are required for initial data collection. And then once the data is collected, we come to the to understand part. We see, due to the noise fluctuation or the medium propagation, it may instill various noise into the raw data. How we are going to filter that data, and then make it in a and then make good interpretations from the data. What are the various algorithms? So we have machine learning algorithms, various noise filtering algorithms are there. How are we going to apply them in order to interpret the specific data that we want for specific stakeholders? And then once we are able to identify and understand the data, how are we going to share this data? Do we have a common integrated platform for that? Is there any particular graphical user interface? We are going to understand that. And this, the UDA helps us in sensitizing the various stakeholders. So we have the outreach phase, where we reach out to the various decision makers or the policy makers, hold various crucial workshops, engage them with the various policy and the technological interventions. And finally, with the help of the user, academy and industry partnership, we have skilling programs that are there in order to skill the future workforce which are going to take up these projects in the field. Then we integrate this with the marine spatial planning for better decision making. The data, the stakeholders, all must be properly visualized and then be shared between the various stakeholders. Thus, what are we looking is understanding how can we collect, how can we go on with the data collection, integrate them with the specific stakeholders, have the policy objectives, the technological interventions, in order to form a holistic, integrated sediment management approach. So this is what our work has been there. With this, I'll end the discussion. Yeah, thank you, everyone.
Thank you, Roman. Next, can we please have Bhavin Jain's presentation? Bhavin is going to be speaking on segment classification ML model. And Bhavin is currently working as an MRC intern, and he's from IIT Bombay. Bhavin, you're muted. You can unmute yourself and start.
Apologies. Hi, I am Bhavin Jain. I am currently pursuing a BTech from IIT Bombay. I've completed my second year and am currently pursuing a research internship from this prestigious institute, Maritime Research Center. And I've been added a research project here, which is basically to provide another path to the problem, which is known as sediment classification. So now I'll be explaining a bit about my project. It's mainly a data science project, and it is based on the Khadakpasla Lake data, which was collected in 2019. At the time, it was collected with a purpose to solve, which is obviously sediment classification. But the method to achieve that was done using mathematical models, such as energy time model or reflection coefficient models, which are basically very heavy mathematical models. A lot of post processing of the data was done to get the final results. So what my aim is to use machine learning algorithms to use this data to provide another alternative to this problem, so that it can reduce time and can also provide us an easy method. Now, before I move ahead with my project, I would also like to tell you about the exactly importance of it. So, sediment classification is basically classifying sediment layers, which Ayush was explaining as well, and Roman sir also explained as well. So now here, what we are doing in the left, you can see the methods which are used presently to do sediment classification, which is remote sensing, uh, uh, image analysis. Then we have diffraction, we have grain sieving. These are the methods which are used presently. These are more physical methods, and again, they require extensive post process. Now, what I will be using will be based on neural networks and support vector machines, which are basically ML types. So now, what will be my roadmap for this project? Now, my project output will be mainly based on 5 inputs, which is time of reflection, amplitude of reflected signals, energy of reflected signals, reflection coefficients, frequency of sonar waves. Now, all of these can be calculated from the data, which is the form of data you can see on the top right corner. So basically, I've been handed signal amplitude values from the sub-bottom profiler, which was the instrument used to collect the data. Now, using the Hamiltonian transform, we can calculate all these values which are mentioned on the top left. And later, I would be dividing this data into different parts to get my training data, testing data, and validation data for my final ML project. Currently, I'm in my knowledge collection phase where I'm trying to understand what the data exactly is and trying to calculate these values of parameters. I'm moving ahead through the course of this internship. Now, my project holds a lot of future potential, such as it can, in the future, if this gets successful one type of data, we can incorporate other types of data. Also, we will need to increase the accuracy of algorithms such that it can be used for high-level research operations. Now, another issue with sediment classification on any research method which is based on ground is that it requires a lot of physical costs and time. So if we use methods which do not require that much on physical interference, such as remote sensing, then we can also eliminate the issue of physical data collection. This can all be done remotely, which will be a very big change in the methods for calculating sediment classification. So now I would like to end my presentation. Thank you for listening to me. Thanks.
Thanks, Bhavin. Next, can we move on to Pradnaya Kumbre from IIT Bombay? Pradnaya is going to be speaking on the topic sediment management transport study.
Hello everyone, I'm Pradnya Kumbhare. Currently a research intern at Maritime Research Center, and I'm currently third year undergraduate from in electrical engineering department. And today I'll be talking about sediment transport study. So let us first discuss why sediment transport is important. So the monsoon season in India, it contributes significantly in excessive siltation. Let's take for example the Ganga River. The Ganga River is one of the world's largest sediment dispersal system, transporting an extremely high suspended sediment load along with it. And the sediment built up during this process, it impacts our water bodies significantly. Our reservoirs are losing their storage capacity, and it is not only about the reduced water storage, but it also increases the flood risk. Hence, addressing the sediment management is extremely important for preserving our environment and ensuring the economic stability. Let us see what are the critical aspects and the effects of erosion in sediment transport. So, as I mentioned in my previous slide as well, the Indian tropical rivers that are responsible for bringing a large quantity of sediment. As a result, it causes immense erosion. Now, erosion and aggregation, these are two most important geological processes. These are the natural forces that are responsible for bringing down large amount of sediments. Now, as the water flows, it transports more sediment along with it if it has more kinetic energy. It not only affects in rising river beds, but it also causes drainage congestion. It affects water flow and navigation. Let's move to who are the various stakeholders in managing the sediment transport. This include government agencies that are responsible for environmental protection, managing water resources. We also have environmental organizations that focus on preserving habitat and improving the quality of water. There are local communities who are dependent on rivers for fishing, agriculture, and transportation. There are many more stakeholders that are involved in sediment transport. I've just listed few of them. Let us see the sediment management simulation models. So in my research project, I plan to use various simulation models for studying sediment dynamics, mainly focusing on 3 case studies that are Brahmaputra Basin, JNPT Port, and managing this sediment in these cases are extremely important for ensuring the economic stability. I'll employ a trust model for Brahmaputra Basin and 12 3D model for JNPT port and Kochi. Lastly, let's move to the overview of future scope to minimize the sediment transport. Initial step is tackling the sediment issue by watershed management. By combining various engineering and bioengineering techniques, we can address the root cause of incoming sediments. Also, managing already deposited sediments within the rivers, it requires innovative solutions like sediment bypass and sediment pass-through interventions. A remarkable solution is being carried out by researchers, that is the bypass tunnels. These bypass tunnels can reduce sedimentation by 80 to 90% according to studies. Yeah, that's it from my side. Thank you everyone for listening to me. Have a great evening.
Thanks, Pradnya. Now, in this set of presentations that we are going through, I'd like to call upon S. Arulanandan from IIT Kharagpur. He's going to be speaking on sediment management focused on dredging. Arun, you can take over and you can start your presentation.
Hello everyone, my name is Arulanandan. I'm a third year undergraduate student from the Department of Electrical Engineering at IIT Kharagpur. I'm currently a research intern at MRC. My project topic is sediment management focused on dredging. First, let's understand the importance of dredging. In tropical regions, excessive sedimentation is a common issue that reduces the depth of water channels, which are crucial for navigation and the economy. The sedimentation issue can also impact the normal functioning of ports and harbors. Dredging helps in these situations by removing the excess sediments from the water channels, ports, and harbors, and thereby ensuring proper navigation. But dredging shouldn't always be the go-to answer to these problems, as they are very expensive and can cause major degradation in the local benthic ecosystem if done without proper planning. My field of research is an understanding how to make the whole process more efficient and sustainable. For example, application of UDA framework to the process of dredging will be helpful in various ways. By using the UDA framework, we can formulate guidelines and can build up a structured approach towards the problems faced during dredging. For example, understanding stakeholders is a big part in planning and designing phase of dredging, which can be facilitated by the UDA framework. As we know, dredging has diverse impacts on economy, ecology, and the local communities. We should develop practices and measures to reduce these impacts. In various parts of the world, different methods are used to tackle these problems. And since Western waters are different from our tropical Indian conditions, many of these methods and practices may be inefficient if deployed in India. Therefore, a study must be conducted focusing on our Indian conditions to reduce these impacts. Let's take a case study that I have done focused on a certain water channel in Brazil. The sediment obtained from dredging proved to be unfit for direct oceanic disposal. So they have adopted a strategy of confined aquatic disposal, which hasn't been implemented in Indian waters. This method is proven to be an effective and sustainable solution for sediment disposal, as harm done to the local aquatic ecosystem is minimized. And considering Brazil is a tropical country like us, these methods of sediment disposal can be adapted to our Indian waters in the future. And here are some other methods that I have observed from my case studies. For example, confined disposal facility is similar to confined aquatic disposal, but CDF is done on land. And pneumatic flow tube mixing is a method to convert fine sediments obtained from dredging into useful materials that are used for construction and other economic uses. And mitigation banking is a method that is often used in western regions. The concept behind this method is understanding the harm done to a region and compensating with improvement and preservation of ecosystem in a different region, thereby reducing the net harm done to this environment. I'm currently researching in calibrating these methods, tailoring to our Indian conditions. Thank you.
Thank you all. So With this, we end with the first topic of the day, which was sediment management. Next, we're going to move on to the next topic, which is ESG, climate change, and blue economy. For this, I'd like to call upon Catherine J., who is the head of publications and research at the Maritime Research Center. Catherine is going to be speaking on the topic related to blue economy in the Indian Ocean region. Catherine, you can take over.
Thanks, Mr. Nishta. Good evening, everyone. My name is Catherine. I am currently heading the Research and Publication Department at Maritime Research Center. I have been associated with MRC for the past couple of years, and I've also done considerable amount of work on marine spatial planning and blue economy from the policy perspective, trying to integrate the policy and technological aspects of blue economy. In this particular presentation, I will be focusing on how UDA can be used to enhance blue economy in India. So a framework for blue economy goals and integrated sustainable ocean management. In this presentation, I'll be covering briefly the background, various challenges in blue economy, and why UDA, and what are the benefits of this approach, and the future scope. So talking about the background, the concept of blue economy isn't new, and it has been there, have been developing in steps since the 1970s Stockholm Conference. And after that, the adoption of United Nations Law of the Sea gave another impetus to the whole initiative. And various other conferences and reiteration of the goals has happened throughout the years. And recently, in 2020, the United Nations declared this particular decade as Decade of Oceans, which has given an additional importance and attention to the ocean economy and ocean sustainability. And following that, we've had a lot of collaborations, a lot of other conferences to talk about, to implement and to plan various initiatives. Today, India's maritime resources is one of the major untapped resources in India. After having used up pretty much gone to the limit of the land resources, we are now, not just us, globally, everybody's looking to the oceans for various resources, food, medicine, energy, etc. And our economic zones are vast because of our vast coastline, and there's a lot of potential and opportunity to take initiatives to make sure that our growing population is indeed catered to sustainably. Various key sectors, as I mentioned, are fisheries, shipping, energy sector, the offshore energy, renewable energy sectors, biotechnology sector, medicine, etc. So I would like to bring your focus to the recent report by UNESCO, State of the Ocean Report 2024. On page 69, I find this statement: persistent gaps in the ocean observing system, both spatially and thematically, remain, and there are gaps, and there is also an urgent societal need for more ocean observations to manage risk and adapt to change in ocean and weather systems and support sustainable blue economic growth. So why this statement? We already have, I mean, the ocean is vast. Is this a viable solution? Getting more ocean observing system, is it viable? Are we working smartly, or are we just deploying sensors and various other satellite to capture images without knowing what to do with all of that data? So what is the smart work that we are missing here? So what we are expecting is, according to the 5 pillars of New Ocean Agenda, is ocean wealth, ocean health, ocean equity, ocean knowledge, ocean finance. These are the expectations that we've drawn. And what is the reality? We are still faced with a lot of environmental threats. We are still faced with a lot of infrastructure burdens for the oceans. Just as I mentioned, a lot of observational platforms, etc., and the failures related to that. It's pretty obvious that the more number of observation stations you're trying to deploy, the number of failures, the number of accidents are also going to be increasing without proper planning or proper idea of what we are getting into. And then data gaps and inadequate monitoring, lack of capability. Although we have a lot of area to cover, do we have the capacity and the capability to cater to all of that in terms of the science, in terms of the technology, etc. And then the stakeholder miscommunications. The stakeholders are diverse. So there are, because of the lack of data, the lack of capability and understanding, there is a lot of miscommunication, which will definitely lead to inefficiency. So all of these initiatives, a sustainable ocean economy for 2050, the future of food for the sea, from the sea, the ocean as a solution to climate change. So in all of this, where is the underwater awareness? So there are three kinds of data we can capture from the oceans: surface, subsurface, and underwater perspectives. So till now, we've been actually looking at the ocean from the perspective of the land. So instead of going from the land, why don't we look at it from the ocean's perspective? So from the deep waters to waters outside. So when we look at it that way, the kind of data that we want to capture, the kind of data ranging from the satellite imagery, the seabed data, the other acoustic data, the data from the AUVs, etc. So we have all this data. We've been doing a lot of it in silos, but the perspective hasn't changed. We are still looking at all of it from above water. So the knowledge generation should also be focused from what we have underwater to what's on above water. So the whole the line of thinking, if we kind of shift it, then our marine spatial plans and the national, the regional plans will all cater to sustainability more than catering to the economy. Although both of them have substantial importance, but if we don't take care of the environment, the economy will definitely die off after a point of time. So sustainability is definitely a key factor, and if we don't focus on underwater, the biodiversity within water is definitely going to suffer. And all of this would require a new kind of capacity, a new kind of capability. And this approach is being offered by the underwater domain awareness, where instead of focusing on and collecting all of that data isn't possible. It's an impossible task. So the best way to go about it is modeling and simulation and using the open access data itself and various other kind of qualitative data as well. So qualitative data till now has not been used efficiently to make plans when it comes to ocean management. Data, socioeconomic data, data on from the satellite imagery, etc. Even though it's been used, I think an interdisciplinary integration with a lot of focus on what the end goal, which is making sure that we are sustainably using the ocean resources, is something that's been missing. So underwater domain awareness focuses on modeling and simulation and interdisciplinary integration of data, which is possible through artificial intelligence and machine learning. And then subsequently we can take it forward with field validation. So the field validation will involve it isn't resource intensive, but will give you the expected results. And capacity and capability building is also an integral part of UDA. So the benefits of UDA includes it's economical and efficient, it's time saving, it helps you make informed decisions, predictive analysis, it's cost effective, leads to cost effective planning, uh, gives you adaptive management strategies, it's resilient and accessible to a lot of stakeholders. So the application is that we have a lot of emergency scenarios where we need quick solutions and quick thinking, which is not possible with just deploying a lot of resources out there without integrating all of that data properly. and the conservation efforts is also aided by UDA. Stakeholder management and participation and livelihood generation. So with future outlook, if we integrate UDA with the national policies, not just blue economy policies, the fisheries, the sediment management, etc., we can get a holistic understanding of what is out there, and will lead to a thinking from the sea to the land perspective. In the future, we are also looking at skilling and livelihood generation in all three categories: research, technology, and the deployment staff. So this will lead to a lot of socioeconomic benefits to the coastal communities as well. Thank you. Thank you for your time.
Thanks, Catherine. Next, can we have Akash Prasad from IT Bombay to make the presentation? Akash is going to be speaking on statistical inference of the climate change impact in the Indian Ocean region.
Sure, Nishtha. So, first of all, a very good evening to the panel. My name is Akash, and currently I'm a third year undergrad student from IITB, and I'm pursuing my majors in material science. As a intern at MRC, I'm working on the project, the climate change in the Indian Oceans and how it has impacted the economic activities over the years and its forecasts. So first, I would like to start with our current scenario and what are the potential threats of the climate change. So I would like to highlight the current scenario. Okay, so based on the suggestion of some famous reports like IPCC and the World Economic Forum, it is very much imperative for us to restrict the temperature change of the globe by one below the 1.5 degrees Celsius by the end of century. In fact, the anthropogenic emission of the CO2, which is happening due to the industrializations and many other things, should decline by 43% and it should peak by 2025, right? And in the scenario, if we fail to achieve this target, then it may lead to the trigger of the climate tipping point, which is referred to the threshold change in the climate, after which the change is irreversible. So yeah, so major threats of this climate tipping point could include that is the melting of the ice sheets from Greenland and Antarctica sheets, which may lead to the high sea levels and ultimately cause floods and other change in the weather pattern. And if we fail to reduce the sea surface temperature by 2 degree by the end of the century, so there would be a sea level rise, of course, of 0.5 meter. So like we are hearing like there are many kind of organizations like COP and various agreement like Paris Agreement and related stuffs are getting passed, but no major impact has been seen on the ground level up till now. So this is a problem of concern. And if we talk about the underwater domain, so major chunk of the blue economy for any country is contributed from the underwater resources itself. And a slight change in the underwater temperature can lead to the various kind of harm to the underwater ecosystem. For example, a slight change in the temperature may lead to the coral bleach, and it may have further cascading unfavorable consequences, from depletions of high quality fisheries productions to the degradation in the seaweed cultivations. And yeah, right, the underwater domain is getting affected in form of the ocean acidifications or the rise in the temperature and the dissolved O2 concentration being decreased. So there's a huge and in fact it has been predicted, right, if the scenario remains the same, there would be a decline in the fishing production by the 21%, and which will lead to the loss of around 300 million pounds by 2050. So I have like included a plot of the time series for the ocean heat content. So what is happening? Climate change had led to an increase in the net ocean heat content over the years, and it is like visible from the graph. There's a positive net heat content over the years, which is quite concerning. And if you see to the world map, and we can see we can have a look that the in fact the tropical waters and all compared to other waters, let's say temperate and arctic, have more ocean heat content, and ocean heat content will lead to the decrease in the oxygen concentrations as well as the phytoplankton, which are essential nutrition for the fishes and other creature to grow. And yeah, so like also the rising ocean heat content has like degraded the quality of the habitable zone for them and forcing them to migrate to some other places, and hence the fishing production for any country is affected due to this. So first of all, I would also like to highlight why it is in fact important for the Indian Ocean to deal this climate change. As we know, like as in the previous slide, I mentioned about the more ocean heat content in the tropical, and in fact, if we go from the facts or the stats, the net ocean heat content is more for the IOR region itself, and because the increasing demand for the IOR region, both from the economic and the strategic point of view, so the world power is shifting toward it, and in fact the IOR itself serves around the one third population of uh, uh, one third world population, being only 20% of the Earth's surface. So, but there is still inadequacy of the technology for monitoring and policy framework, and the existing policies are very much influenced by the Western power. So we have to build a framework to deal with it. In fact, the UDA framework, which is proven to be very much efficient for addressing this problem. So I would take some time to explain what the UDA framework is. So UDA framework, as we can see, there are 4 different sections. The first one is the capacity building and collaboration with the community, right? Which includes involving the right stakeholders and taking actions for their upscaling. Next is the digital transformation, involve the planting sensors to collect the data parameter for the ocean parameters, and this will help to plan to offset any potential threat. And next is the marine spatial planning, which is a precise mapping of the resources underwater. This approach will help proceed in the proper planning and take care of any important resource, right? And the last one is the surveillance and the surveillance and monitoring, which refers to the continuous monitoring required for the ocean. So with that, I would like to conclude my presentations and like to wish everyone a happy World Ocean Day. Thank you.
Thanks, Akash. Next, can we have Anjali Kumari from IIT Kharagpur? She is going to be presenting on the topic water resource management.
So first of all, good evening everyone present here. My name is Anjali and I'm a third year undergraduate student in the Department of Chemistry at IIT Kharagpur. Currently, I'm working as a research intern at Maritime Research Center, and my research topic is water quality management system. So today I'd like to present a short presentation regarding my work. So the topic for today's presentation is water quality in India, a contemporary perspective. So moving on to the next slide. I have been researching since last month and had a lot of literature survey on this topic from different institutions like IIT Kanpur and research reports from Center Board of Pollution Control, etc. There I found that 70% of India's surface water has already been contaminated, and I found that there are a lot of factors that affect the water quality, and among them one of the key factor is increasing urbanization. That is basically the industrialization, where we are using fresh water. Basically, in fact the drinking water, which is not essential for industrial purposes. Then, what is the importance of my topic? That is to ensure safe drinking water, sustainable agriculture, and healthy ecosystem. Then my goal is to identify key pollution sources, assess its impacts, and propose optimum solutions for that. Then what are the significance to protect public health, support economic growth, and preserve natural resources. So now, what are the optimum solutions for a water quality management system? So as we already know that there are already a lot of technological interventions that have taken place, which aim to integrate advanced technologies for a water quality management system. But what we and different stakeholders need to understand that the policies and the frameworks that are written on the papers need to be followed in real and at a ground level, because it has already been too late to focus on this issue, and we need to have that fear of huge scarcity by the next few years. What my approach for this is that, first of all, I had a rigorous research on the topic, wherein I had gone through a lot of research reports, existing methods, and available data. And currently, I'm analyzing what are the technological and policy gaps in those available methods and data. And finally, I would be proposing if there are some better solutions for the existing solutions that are available. If yes, then I would be incorporating in my research note. And yeah, however, the best solution could nothing be better than the prevention rather than cure. So we need to understand the seriousness of this problem. So finally, what are the future scopes of this solution? So once I complete my research and I'm at a stage of proposing some unique solutions to those, I would be incorporating them with the UDF framework, which has 4 components like blue economy, strategy, security, digital transformation, and sustainability and climate change. So with this, I would like to conclude my presentation for today. Thank you for your attention, and have a very happy World Social Day. Thank you.
Thank you so much, Anjali. Next, so this was the end. Anjali was concluding the set of presentations for the topic ESG, climate change, and water resources. Next, we'll move on to the next topic, which is digital transformation. And this topic is going to be led by Shlok Nimani. Shlok is a fellow at MRC, and he's done his studies from IIT Bombay previously. Shlok was an intern like some of the interns that you can see right now. He was also one of the interns, but currently Shlok works as a fellow at MRC. And in today's presentation, he's going to be speaking about digital transformation for sustainable economy. Shlok, you may take over.
Hi everyone, welcome to my presentation on digital transformation for sustainable economy. Myself Shlok Nimani, I am a research fellow at MRC. I am with MRC for over around 2 years, and I have been completing my BTech and MTech from electrical engineering from IIT Bombay. Will be graduating very soon. So here, why are we even talking about all this? Why have I started talking about the blue economy, the sustainable economy? So here on the left hand side, one can see how the overall production of shrimp in India have been increasing in the past decade. So this all has been attributed to the introduction of venomous shrimp. On the second hand, on the bottom right, bottom left, one can see on the global scale the shrimp production over the years. So there has been a monotonic increase over the years. But the idea is, what is the share of aquaculture versus the capture fisheries in. So here we are not only talking of as per the shrimp, but the idea is in the past 3 to 4 years, we are seeing a very much interest of the parties as well as the government organizations toward the growth of fisheries and aquaculture in Indian Ocean region. So here, as the director of ICARD and CMFRI, Gopal Krishnan sir has mentioned that India has the potential of producing about 10 million metric tons of seaweed. And you will be like astonished by seeing the number which we are currently producing as per the last financial year, which is roughly about 35,000 metric. But on the better note, we are touching our all-time high exports of seafood worth 8 billion US dollars. And the frozen shrimp, why even I am very much interested in this particular species or the organism is like it remained to be the major contributor to the total export basket. We export our shrimps not only to China, but also to the West. And this our blue economy policy of 2020, it mentioned how India need to bind to global IUU regulations as well as the changing climate condition in IOR. As my colleague Akash has pointed out, that change in sea surface temperature can have a significant impact on change in the potential fishing. So India is pushing towards the mariculture, aquaculture, and the seaweed farming. In terms of economy and ecology, it looks all good, but what else? So it also supports the livelihood of many. About 30 million livelihoods are supported by the people employed in fisheries and aquaculture. Government is taking a step by has been introduced the flagship scheme of Pradhan Mantri Matsya Sampada Yojana, and which aim to boost the growth of aquaculture and fisheries in the country. It also aimed to make this aquaculture industry highly rewarding because most of the farmers employed are the small scale farmers. So inclusivity of the aquaculture imparts the point that it needs to sustain their livelihood by generating larger income. So that requires a sustainable growth in terms of economical aspect for these people. So here we are trying to promote skill training and knowledge transfer at MRC along with technological interventions for the same. How UDA comes into the picture. So let's take the two phase of this multifaceted UDA framework. The one is the marine environment as a part of economy. So what we are trying to say that the anthropogenic activities, if taken out recklessly, what I mean here in terms of capture fisheries, a lot of bycatch is also captured while the wildfire fishing. In terms of aquaculture, a rampant increase in the land of aquaculture can generate conflicts with agriculture and salt plains, as well as mangrove destruction is one of the key problems, or the attributor of mangrove destruction is most of the time given to the rise of aquaculture. Second is the digital oceans, where we are saying the tech for good or the maintaining the inclusivity or equitability of the increasing aquaculture in the country. And what is the idea here is the sensors can see much more than what human eyes can do. There are a whole lot of hardware complexities involved regarding sensors, as my colleagues has pointed out that they can be acoustic, they can be vision sensors, and what all it helps us is to like aid to the 2C to understand and to share framework. So here let's begin with understanding the very basic of digital transformation. So under the digital transformation, I would like to bring the MSP umbrella. So this umbrella of MSP, it likes to bring the coordinated decision of the stakeholders like fisheries, aquaculture, energy, transport, as well as the conservation and recreation of the benthic ecosystem. So idea is you need to take the justified allocation of resources so that all the steps between these stakeholders are coordinated and no resource conflicts takes place. So what are its applications? So in short, I would like to say that the justified allocation would bring ecological, social, and economical harmony. In terms of harmony of ecological, it would mean a better term would be a ecological sustainability. While for the policymakers, this MSP can be a data-driven tool. So this is a data-driven tool for policy making. In terms of ROI or the return on investment, we are already moving under the government scheme of Pradhan Mantri Matsya Sampada Yojana, which aims to reward the growth and growth of aquaculture. So idea here is, if I talk about the aquaculture growth, so are we really focusing on the productivity, or are we more concerned with the increasing area? So my colleague Shashank will point out next about what is area concerns regarding the aquaculture expansion. Finally, productivity as well as data.
Hi, Shlok, can you hear us? We can't hear you right now. Thanks. I think with this, Shlok has concluded his presentation for today. And next, we'll move on to the next presentation, which is by Sushank Chigipalli, who is from IIT Kharagpur. And he's going to be talking about aquaculture demographic digital mapping. So I'd like to call upon Sushank.
Hello everyone, very good afternoon, and I'm Shushank Chigipalli, an undergraduate student from the Department of Civil Engineering at IIT Kharagpur. I'm a summer research intern at Maritime Research Center, Pune. I wish you all a very happy World Oceans Day, and I'm currently working on open pond agriculture demographic mapping using satellite imagery and computer vision. Next slide. Mangrove forests sequester carbon much faster than other forests, so they are vital in fight against the climate change. When mangroves are degraded or lost due to coastal agriculture, particularly shrimp farming, they release stored carbon stock back into the atmosphere, thus significantly contributing to the greenhouse gas emission. Nutrient transport due to this clearing of mangroves to adjacent ecosystems like oceans causes biodiversity loss, such as seagrass, meadows and coral reefs, and also exacerbates the climatic variables. The extensive clearing of not only mangroves but also the agricultural land led to the conflict between agriculture and shrimp farming, resulting in land and water degradation. This shift has affected traditional livelihoods and employment opportunities of locals, as agriculture is less labor intensive compared to agriculture. Despite these efforts, they play a vital role in food security and blue economy. So it is crucial to find a balance through sustainable practices. This requires identifying suitable land for agriculture and tracking agricultural demographic changes in the landscape to enhance spatial planning. Next. Remote sensing, particularly using synthetic aperture radar, SAR imagery of Copernicus data space, is crucial for my project on mapping agriculture demographics. SAR's ability to penetrate through clouds and vegetation, which allows us to collect consistent and reliable data regardless of weather conditions, ensuring continuous monitoring of coastal and aquaculture areas. This technology covers large area with less revisit time and also reduces the need for extensive fieldwork. This helps us to monitor the ponds at very low overall cost. Unlike traditional surveying methods, which are labor intensive, remote sensing provides object to high resolution data that can be analyzed with advanced technologies like Geographic Information System, GIS, and computer vision. We use 3 computer vision models for our project, ResNet, Deep Lab, and Temporal Convolution Networks. This enables spatial mapping, precise spatial mapping, tracking of changes over time, supporting sustainable agriculture management and minimizing conflict with other marine users. Next. In my research, we utilize Sentinel-2 data due to its high resolution multispectral imagery, which is crucial for identifying changes in land use and vegetation health. Additionally, we integrate OpenStreetMap dataset to enhance the accuracy of spatial maps. We use sensing technology to precisely identify the graphic coordinates of agriculture points. This accuracy is crucial for detailed spatial mapping, ensuring that we know exactly where these ponds are located. By measuring the area of each pond by demarcating them, we can access the scale of agriculture activities and monitor the expansion over time. This data is essential for evaluating the environmental footprint of agriculture. So, understanding the lifespan of agriculture ponds, which ranges from 1 to 22 years, helps in planning sustainable practices and predicting future productivity. And it's also useful for developing sustainable management practices. Yes. Okay. In this image, in the right image, we can see how we can see the agriculture ponds are encroaching upon the surrounding areas. So by tracking these changes, we can effectively monitor environmental impacts such as deforestation and increased carbon emission over time. This information is crucial for developing sustainable management plans that balance the economic benefits of agriculture with the needs to protect coastal ecosystems. Additionally, the data helps policymakers to mitigate negative effects and promote practices that ensure coastal environments long-term sustainability and resilience. In the left side image, we can see how mangroves are growing themselves naturally just by changing the by understanding the hydrodynamic flow patterns of the local area. So, revisitation of abundant agricultural regions should also be priority for integrated coastal zone management. At times, series of very high spatial resolution optical satellite images reveal that the trend in the evolution of these mangrove forests within the aquaculture form. The results showed that the mangroves are expanding both inside and outside the pond. So, next. This is next. With this, I conclude my presentation, and I wish you all once again a very happy World Oceans Day. Thank you all for your time and attention. Thank you.
Thank you. Thanks, Shashank. Now we have the concluding presentation for this topic, and I'd like to call upon Aryan Awad from IIT Kharagpur. He's going to be speaking on the topic collision avoidance system using AIS data. So, Aryan, you can take over.
Good evening, everyone. I am Aryan Awad. I'm currently a third-year undergraduate at the Indian Institute of Technology, Kharagpur, and I'm currently pursuing a Bachelor's of Technology in Mining Engineering. I'm also a summer research intern at the Maritime Research Center, where I'm working on a project to develop an enhanced collision avoidance system. The need for basically this project deals with developing an automated system for detecting collision probabilities based on state-of-the-art AI models and satellite image data. Now, first, to understand the importance of the project, we need to realize the need for a collision avoidance system. So, as you all know, maritime transport serves as a cornerstone of the global economy, facilitating international trade and exchange of goods across the continent. Currently, as we speak, there are over 100,000 ships sailing simultaneously at the sea across the entire world. And to promote the global economy, the ship traffic has surged by great numbers in the last few years, and it has almost quadrupled from the period of 1990 to 2012. And even as we speak, it's going at an astounding rate of 10% every year. With such increase in maritime traffic, the collision risks are also bound to increase. And as you can see from the data, about 1/3 of all the accidents related to marine traffic are related to collisions. And these incidents not only cause a financial loss of over $2 billion every year, but also cause an irreversible damage to the environment and marine life around the collision area. Now, since we have understood the need for a collision avoidance system, let us take a look at the existing technologies to solve this problem. Now, first we have radar and remote sensing technologies that use on-device sensors to detect the presence of nearby ships. And the problem with these type of technologies is the input data for these sensors is very limited, and they cannot accurately predict the trajectories of the ships around them and can only predict their locations. And then we have the Cold compliances. The Cold compliance basically stands for the Convention of Maritime Laws for Ship Regulations and Transport. And these laws are basically a set of rules that were established in 1972. And since then, the marine traffic has increased so much that they are not sufficient anymore to prevent all the collisions that can happen in high traffic dense areas. And then we also have some algorithmic methods that utilize predefined data or knowledge and only offer a rule-based approach to preventing collisions. They cannot take into account the real-time data, and this is one of the major drawbacks. So, looking at all these drawbacks, I have proposed a new method which uses both the AIS and satellite data and also the state-of-the-art AI techniques to solve this problem. Now, with satellite data readily available, it's almost imperative to use this for our project. And the main reason is with the availability of SAR data, it's very easy to recognize ships in high traffic areas from the satellite over a huge area, and not just the areas pertaining to one or two particular ships. With monitoring such a huge area, we can develop algorithms that can detect the location and orientations of multiple ships and detect the collision probabilities in case there are any. Also, while dealing with the satellite data, we can use state-of-the-art AI models, which basically use computer vision technologies like the UNet, ResNet, or even transformer models that can very accurately detect the location and orientations of each and every ship present inside the area and can calculate probabilities of collisions even if there are very minimal chances. And this is just a high-level overview of how our project implementation is going to look like. And this is the data that will be captured by the satellite. And mostly we'll be focusing on areas that have very high marine traffic and hence higher collision risks. And as you can see, we can identify the position and orientations of each ship present in the particular region, and we can sort of map the commonly taken ways and calculate the collision probabilities and risks based on certain threshold values. So this was the idea of my project, and thank you everyone. I also wish all of you a very happy World Social Day.
Thank you. Thanks, Aryan. Thanks for your presentation. So this was the end of the topic called digital transformation. We lost Shlok in between. He was still left with a couple of more slides, but because of like internet connectivity that he's facing right now, he requested if we can continue with the presentation. I'm not sure if he has been able to join us or not, but by the end of the other presentations that we have, we might have Shlok join us again and finish his presentation later on. But right now we'll move on to the next topic, which is underwater radiated noise management. I'd like to call on Akshita Mangal from IIT Delhi to make her presentation. She's currently working as an MRC fellow, and she'll be speaking on the topic ambient noise mapping.
Good evening, everyone. I'm Akshita Mangal, and I'm currently a research fellow at MRC. And I'm also a fourth year at IIT Delhi, and coming from my majors is in mathematics and computing. So the topic of my presentation will be ambient noise mapping, and here is the flow of the complete mathematical equation, source level, transformation laws, conclusion, and differences. So first of all, I would like to introduce you the topic that I am going to speak about, which is the estimated radiated noise. So the estimation of radiated noise from the marine vessels has become an important research challenge, considering that marine animals basically use acoustic signals to communicate through each other. There is no, because most of them are blind, just the way we have dolphins. So the only way they can communicate is through the acoustic signals. So shipping noise is basically the single source of the ambient noise in the ocean. Now, because of the human interference in the oceans, these sound signals actually interfere with the signals produced by the animals. So there is a need for us to measure, to at least get the idea of where the source level is more, where this noise is less, etc. So the Indian Ocean region, the main topic or the research arena for me was the Indian Ocean region, and it has emerged as the most critical sea area in the 21st century. The shipping traffic due to the merchant marines and the naval deployments have seen a manifold rise in the Indian Ocean region. Now, why is there a need for such measurements? Enhanced shipping traffic directly translates to the significant increase in the low frequency ambient noise levels, and this impacts the acoustic habitat degradation. Just because of this much of the shipping traffic, maybe due to the, you could say because of the trade, because of the military purposes, because of the reasons, This leads to acoustic habitat degradation, which has a very, very major impact on the aquatic animals and also the coral reefs or maybe the other habitat over there. Marine species are known to depend on sound for functions like foraging, communication, navigation, finding mates for breeding, and more. Naval warships need to evade detection by their adversaries and thus have a critical requirement for acoustic stealth. Precise estimation of the radiating noise from the marine vessels will contribute to the acoustic capacity building and go a long way in ensuring effective realization of the underwater domain awareness. Now, coming, I actually mean by is this, but is that noise is just a normal equation, a mathematical equation that it follows. So noise level is equal to the source level minus the transmission loss plus some of the error terms. Just because this noise calculation is an empirical thing and accommodate every empirical thing in a mathematical equation, there is some of the error terms. That's why we have the error term with us. So essentially, my topic, or you could say this research work, was divided into two parts. First of all, calculating the source level, and then calculating the transmission loss, and finally clubbing both of them together. Now, just subtracting them, we can get the noise level of a particular region. So SL basically represents the initial intensity of the sound source. The received noise level is the NL, represents the sound intensity at the receiver's location. Now, this noise level will be further, you could say, will be able to frame a heat map using the that will basically the transmission loss, or it accounts for the attenuation of the sound energy due to the spreading of sound waves over distance. No, source level. So what happens is that the calculation of source level basically come from different models. There has been lot many models, like 4 of them I have kind of listed. Awaken model, the Morris and Harvey model, Harbor, Porpoise model, the sonar performance models. So basically these models have different time zones, and also they were effective, or you could say the most effective in different arenas. But the status quo is that the Awaken model, with the current modeling of the ships and the infrastructure that we have, predicate models are the most famous models. So it's important to note that specific models and methodologies can vary depending on the particular source of interest and the available data or information. These models provide a foundation for estimating the source levels, but there are adaptations. So essentially, the Vatican model cannot be used everywhere. There are different bathymetric profiles, sound profiles for different areas. For our purpose, we have kind of made necessary changes and adaptations. The Vatican model, or the Vatican model, is widely used for estimating the source levels of the ship noise. It takes into account parameters such as ship speed, ship tonnage, propeller characteristics, and the operating conditions. Now, what we basically, we generated a data set using the Vatican model, and this being would also been trained on data registries and the real world recorded data clubbed together after proper validation has been used. Now, this data that we find record has been to train the initial AI by efforts cleaner used AI tools. Radiated noise prediction using model from the data from the ES. From this data that we got, we were able to get the source level. Next step was the so for the transmission, deep focus model of the waves in the Indian Ocean region, taking into account and the other interactions, multipath property. Efforts, transmission loss. Now, further, Open implementation has used this function made is the numerical integration of the wave equation. Now, depth model actually just what we got data from range model and then a deep neural network. Now why? The basic RAM requires and with profile, sound profile, CPU density. Consider maybe we the compound function to accurately estimate the transmission loss. Now when we look at the function, but that particular data set, right? And just
Akshita, I'm sorry for
there in one of you can answer.
Akshita, your voice is breaking a lot. I think there's some connectivity issue at your end. Yeah. Am I audible to you, Akshita? So I just want to check if Akshita's voice is breaking for everyone or is it just me? It's breaking for everyone. Okay. Akshita, no, the image is not visible currently if you're trying to show an image.
To me, ma'am.
Okay. All right. Do you want to just try if you can, but otherwise your voice is breaking a lot.
Yeah, I'm trying to.
Let's move to the next, Nishtha. It's not audible at all.
Yes. So I think we'll have to move on to the next presentation. Yeah, it's okay.
Can you just conclude it?
Sorry, can we have Shweta Varshini from IIT Madras to make her presentation now?
Good evening, one and all. I'm Shweta Vishni, pursuing my BTech Chemical Engineering from IIT Madras, now an MRC intern. Happy to present my topic today, underwater radiated noise management. And we will start with two important questions to be answered. Why is this topic and who are important? So let's start with the section of why. Here we will be discussing about the importance of the topic. Firstly, we have protecting marine life. As we all know, going underwater, the intensity of light goes reduces, and the only effective way of communicating or sensing things would be through sound. Accordingly, marine animals, especially waves, dolphins, and fishes, rely heavily on sound for communication, navigation, finding food, mates, or warning each other of dangers, and for all their basic needs. So URN disturbs these sound signals of the animals, and also excessive URN can stress the animals, and which can lead to organelle damages. Overall, it collapses the whole marine ecosystem. Secondly, we have scientific research. Almost all scientific researchers underwater rely on sound recordings for data. Excessive URN again disturbs the sound recordings and makes it difficult for the scientists or researchers to collect accurate data. Thirdly, we have national security. URN management focuses on noise-friendly military vessels, which makes it harder for the enemies to detect our military vessels and enhancing the national security. Now we will move on to the who section. Here I have listed down important stakeholders involved in URN management: environmental groups, marine researchers, shipping industry, military and regulatory bodies, fishing industry, general public, and tourism industry. Moving on, here we will be discussing how UDA framework acts as a tool for URN management. It helps in data collection and sharing, improved monitoring and enforcement, collaboration with stakeholders, and cost effectiveness. UDA framework relies on various technical methods such as sensors, satellite imaging, modeling and simulation, and other digital tools to gather information about the underwater activity, and also helps in collect real-time data collection for monitoring purpose. Since there's already an existing UDA frame infrastructure, it helps us to reduce the additional costs associated with delicate URN monitoring programs. Moving on, this is something interesting about the topic. Uh, Not like any, like it's a unique advantage of URN management. UDA, MSP, and URN management all works together and helps each other. In case of UDA and URN management, UDA can leverage its data collection capabilities to monitor URN levels and identify noise hotspots. Wider versions through URN management can improve UDA's effectiveness. In case of MSB and URN management contributes to achieving the sustainable use of marine resources that MSP aims for. In case of UD and MSP, both benefit from a comprehensive understanding of marine environment. They can share data and collaborate to achieve their goals. Here I have listed down technological and policy interventions that are in place of action and under research. In coming to technological interventions, we have quieter ship design, quieter sonar technology, bubble tapping devices that helps in reducing noise from the propeller gravitation, and noise cancelling technologies that are under research, and improved underwater monitoring systems. In policy interventions, we have international regulations, economic incentives, marine protected areas, environmental impact assessments, research and development funding, public awareness campaigns. In this project, I like to view the topic from environmental and socio-economical dimensions and study the potential area of applications, do a literature review of technological and policy interventions, and identify gaps and solutions through these interventions, and of course, ensure a sustainable development. And I like to conclude my presentation with a sweet quote: save the oceans, as Earth won't be the same if the major part of its constituent goes polluted and dead. Thank you and happy World Ocean Day.
Thank you, Shweta. With this, we conclude the previous set of topic that we had, which was on URN management. And next, we move on to the last topic of today, which is maritime security in UDA. And we have one presenter for the same. Can I please have Shraddha Gajiwal from Symbiosis School of Liberal Arts to make her presentation? Shraddha is going to be speaking on the topic maritime security in UDA, exploring the non-traditional threats and challenges.
Yes, I'll just share my screen. So good evening, everyone. I hope I'm audible. Yeah. Good evening, everyone. Today's presentation is a brief about my topic, about my project on the topic maritime security in the underwater domain. Moving on to the introduction, maritime domain awareness is a critical component of maritime security, which includes the effective understanding of anything associated with maritime domain that could impact security, safety, economy, or the environment. However, this concept needs to be extended to include underwater domain awareness, which specifically addresses the unique and increasingly prominent challenges and threats lurking beneath the ocean surface. The hidden depths of the ocean, once considered inaccessible and secure, have now emerged as arenas of potential conflict and illicit activities. This presentation on my project aims to explore the non traditional threats and challenges in the underwater domain, such as submarine espionage, sabotage of underwater cables, and underwater drug smuggling, etc. In the same context, the main aim of the presentation would be analyzing the policy gaps and the role and the importance of underwater domain awareness framework in mitigating these issues. The choice of this topic is underscored by contemporary examples such as the alleged Russian sabotage of undersea cables, Chinese spy ships lurking in the Indian Ocean, and the use of narco drones or autonomous underwater vehicles for smuggling drugs to Australia, illustrating the pressing need for improved underwater security measures. Moving on, A very small brief about the issues. These underwater threats, as mentioned above, pose significant challenges to national and global security. Submarines, with their stealth capabilities, gather intelligence undetected, exemplified by Cold War incidents like the Soviet K-129, etc. Undersea cables, critical for global communications, are vulnerable to sabotage, as seen in the 2017 Syria outage, impacting financial markets and military communications. Furthermore, drug cartels increasingly use semi submersibles for narcotics transport, complicating detection efforts due to their low profile and ability to operate beneath the surface. Moving on, underwater maritime security confronts significant policy gaps characterized by fragmented regulations, inadequate technological infrastructure, and limited international collaboration. Current policies lack coordination among stakeholders and fail to address the rapid advancements in autonomous underwater vehicles and unmanned drones, etc. Insufficient technological capabilities, particularly in regions like the Indian Ocean, hampers the effective underwater awareness. Additionally, the reluctance to share the sensitive data due to national security concerns hinders collective efforts to combat these underwater threats. And moreover, legal definitions and frameworks are outdated too, complicating the application of rights and duties for operations or activities which involve uncrewed vessels or remote control activities. And most importantly, the Maritime Domain Awareness Framework, which was established in 2005, overlooks underwater threats, lacking comprehensive strategies for detection and mitigation. Addressing these gaps requires a multifaceted approach to tackle these issues. Now comes into the picture the UDA framework. The UDA framework is pivotal in enhancing maritime security and resource management by providing robust threat detection and response capabilities. Through the deployment of advanced sensor networks, UDA enhances surveillance and improved monitoring system that ensures that potential threats are detected early, allowing for prompt and effective responses. And moreover, strengthening international collaboration is another significant advantage of implementing a UDA framework. It encourages data sharing and cooperative efforts among nations, addressing common underwater threats more effectively. By fostering or developing international cooperation, the UDA framework helps in creating a unified approach to managing and mitigating underwater security risks. Moreover, the UDA framework optimizes resource utilization and promotes sustainable economic development. By providing precise information on underwater resources, it enables better planning and execution of security strategies, reducing the strain on military resources. Lastly, the UDA framework integrates data from various sources, including sonar systems, satellite imagery, and maritime patrols, to provide a comprehensive understanding of underwater activities, leading to effective identification and analysis of certain threats. And response strategies under the UDA framework are multifaceted, involving rapid response units and coordination of international naval forces. By providing real time data to decision makers, the UDA framework enhances the ability to respond effectively to potential threats. Um, to conclude, the evolving nature of these underwater threats necessitates a proactive and collaborative approach to maritime security. The intergovernmental organizations such as BIMSTEC, IORA, and the Indian Ocean Naval Symposiums, and many more, should incorporate the UDA framework to strengthen their security efforts and address the unique challenges of the underwater domain. The UDA framework offers a promising solution, enabling nations to navigate the uncharted waters of underwater security with greater confidence and effectiveness. And these are my list of references. Yeah, that's about it. Thank you so much.
Thanks, Shraddha. Thank you so much. With this, we conclude today's presentations on various topics, including sediment management, climate change, blue economy, digital transformation, underwater radiated noise, and maritime security. We shall now move on to the next segment, which is also the concluding segment, wherein we'll have the esteemed dignitaries who will share and we will request them to share their feedback and also their kind remarks. So we have with us Mr. M.V. Ramanamurthy from the National Center for Coastal Research. Sir has been involved with the Deep Ocean mission as well, and he currently is working with the National Center for Coastal Research of the Indian Ministry of Earth Sciences. Sir, can we have you for your kind remarks now?
Thank you very much. And then first of all, happy Ocean Day. And thanks to Commander Arnab for calling me for this webinar, especially. And then it is almost like a different kind of webinar because I've been attending in World Ocean Day where I will be giving talk and then others will be listening. I think it was something different than what it is there. And happy to see a very good presentations by many number of students. They are enthusiastic, and then also some of the information what they gathered and then presented, it is apt, and then they are in right direction. And I also compliment MRC for this important initiative of calling interns, especially from academia. Most of the people, I think the students are from the IITs, which makes it a lot of lucrative for the future blue economy policy that is going to be implemented by the government of India. In fact, though it is only at the beginning, but most of the things have been captured by the students from the various IITs and then other universities for that. And my compliments to all the students who have presented the important topics which is relevant for the blue economy. Because I will be reading some of the topics here and there from the policy perspective and technical perspective. I'm really happy to see such a wonderful comparison from the youngsters and then who gathered the right kind of information and then projected today for that. So this is about the compliments from my side, but other side for the improvement of MRC, what I also suggest is I think some of the presentations, what they have presented on the right direction, but I feel that suppose if some more information is given to the students, instead of starting from the scratch and then getting into the internship and then going forward, maybe you can explore the opportunity of some of the experts who are all specialized in especially UDA. I'm not telling exactly on the UDA, but applications related to the ocean. So that will help them in identifying the right kind of problems and also understanding the practical problems for the solutions what needed from the country in the future. And also while doing such kind of internship by the students, they will also enjoy because they are actually implementing the what is required for the country, and then it is being taken up by the some of the institutions within the country for that. This is my first observation. The second one is on the marine spatial planning. I think you are looking at in a different perspective, but I saw when we develop MSP, our focus was mostly on the resources. I think they're focusing on the economy, inclusive development, what we call it as a society, and then finally the ecosystem, which is very important for the future generation, and then how do we protect while balancing the development in the future for that. MRC as such, the perspective when we see for that, especially when we draw the MSP to update all the students also today on that, I think mostly Arnav knows about that. We have a regulation called coastal zone regulation, which talks from the high tide line in the sea. That means where the water reaches up to the highest point and then 12 nautical miles into the sea. This is where the maritime universities or maritime boats will come into the picture. But when it comes to the blue economy, we are going beyond the maritime zone. That means 12 nautical miles up to EEZ, that is 200 nautical miles, where MSP plays a very important role when we take about the territories of the Indian water is concerned. But of course, MSP is not restricted only to the EEZ. It also goes beyond EEZ, that is called as a international waters, and then the treaty law. How do we handle security in terms of surveillance and all? Completely, it is different once we cross the EEZ for that. So these are all the some of the issues I think we should make students to be aware of those things, and then so that because it is not possible for them also in the short time to get all those things and then present whatever is required for that. But some information has been provided to this youngster. I'm confident that I think they will really make wonders and wonders what is required for the future for them. especially when we are seeing about 70% is covered by the ocean, and either it is resources or climate, if it is controlled by 30% from the land, and what need to be done on the ocean when we have a 70% of the ocean, which not only controls the climate, but also helps in so many other ways in terms of resources, transport, food, especially fisheries and other things. But now our greediness, we are slightly spoiling entire thing. That's how climate change is also one of the major cause of our own not having a thinking about how do we protect the future and then conserve our for the future generation for that. So that makes it more understandable, and then also to see how do we protect and conserve for the our next generation what has happened. I think this time you might have seen these temperatures going up to very high as much as that. These are all the consequences of our luxury and greediness for that. So it is not that we don't want development for that, but at the same time, how do we balance the development, understanding the impact or damage that what you are causing to the climate. The damage will happen in one day, but restoration will take, it can be months, years, and even decades to get back to the normalcy for that. So we have to be very cautious in conserving and protecting the ocean for the our future generation for that. And then all the presentations which were made by the youngsters are really wonderful, beautiful, and then it is apt for the ocean for that. I don't want to bore because I think you already taken a long presentation for that. If I speak more on that, again, I will also think that, oh, this guy is coming and presenting at last minute, lot of stories for that. We should not do for that. Let us see how do we work together with youngsters and then see which they like and enjoy and contribute to the country and also to the world ocean. Thank you, Mr. Arnab, and then thank you, moderator. I think your moderating was wonderful. I think keeping in the time and then bringing all the people on board for that. Thanks to both of you and thanks to the MRC. Thank you.
Thank you, sir. Thank you very much. We definitely take note of the points that you have said. And as you said, sir, we will start our discussion with you and request your time so that we can present, because today there was a short time. We have been also doing a lot of documentation ourselves, and we would like to share those details with you and then work under your guidance to contribute to the larger national cause. And your words will be definitely be important for us because, as you rightly said, sir, I mean, since we work on policy, the government's views and the policies are very important. I am part of the Blue Economy Task Force of FICCI. So we have some understanding, but definitely there is a lot more to be done. And there are so many aspects to be learned. So we will definitely take this conversation forward and really thank you for sparing your valuable time and joining us today, sir. Thank you very much, sir.
Thank you.
Thank you,
We
sir.
can end the thing. Thank you very much. All of you made a very good presentation, as sir has also acknowledged. We are quite pleased with your work and we need to take it forward even more. Thank you all. Thank you so much, sir.
Thank you to all.
Thank you, sir. Thanks to all the interns, all the fellows, and all the internal team members for making this wonderful day special for all of us and for doing a great job at your presentation. Thanks a lot. With this, we close the webinar.
Mr. Great job. And Mehul, thank you very much. As always, great job.
Thank you, sir. Thank you.
Thank you.
Thanks, everyone.
Thank you, sir.
Thanks, Nishta. Thanks, everyone.
Thanks, Catherine.